We got the first portion of that repair panel put on there, the biggest part of it, and that was to cover over the damage done by whatever it was that was in the back of that float that got banged around in there. I was hoping to get it all done, but it took us about 6 hours or so just to do this much of it. And I needed to get it all done at once so that we could utilize the working time of the adhesive of the sealer that I used. And this is the sealer that I used here, 3M marine adhesive sealant 5200. Stuff actually worked out pretty good. Once it got out there in the sun and warmed up, it softened up and it stayed sticky the whole time that we were doing it. I used the 4X rivet gun, and the only thing I've used it for in quite a while was just as a punch to knock those bolts and stuff out of the floats when I took them apart. So it took a little bit to get it set up, and then we used number 5 rivets, 5/32 and 470 AD5s, and they're quite a bit bigger than what I've been using here lately. I've been using mostly 3s and some 4s. It took quite a bit more to knock those down. I was started out on this rear row here for practice row, getting the rivet gun set up and everything, and we screwed up on, I don't know, half a dozen of them, 6 or so. Mostly when we got in here towards this, where this doubler plate here is here on the back, because it couldn't hold a bucking bar in there on their square. So anyway, it took a little bit. We finally got it all figured out, and then we did the rest of these. Now my wife held the gun and I did the bucking bar, and we had to roll the floats over so the bottom here was down, and she sat down on the ground and was pushing up on it, and I was up on top reaching down through that hole and holding a bucking bar on each one of those. And that was kind of a challenge. These ribs here, these rows here go through the ribs, and the ribs are, I don't know what they are, 3/4 or 1 inch bulb angle. So there's a bulb on the angle that these rivets go through, and you can't get a bucking bar straight on there. You have to use a bucking bar that's relieved to fit around that angle. And then of course reaching in through the hole, you can't see what you're doing, you have to feel it. I only managed to screw up, I think, 5 or 6 rivets. I think we did 3 on that side and 2 on this side that we drilled out after we got all done and replaced them. We did all these back here and got it all set up to do with the 4X gun, and then we shot 1 or 2 rivets in the body here, and then the 4X gun froze up, so I had to go dig out the 2X gun, and I had to set up the air to almost 100 pounds for the 2X gun, and it just doesn't work very well on those number 5 rivets and those 5/32 rivets, especially an AD rivet. It probably would have worked better if I used regular soft rivets, but I was using AD rivets, the hard rivets. It just took too much hammering on it. By the time you get them hammered a few times and look, and then the rivets start hardening up, and the next time you go to hit it, they just won't shaper anymore. But we did that for a while with that and got several of them put in, and then it was hot. It was 80 degrees or better out here yesterday, and we were out in the sunshine here, so it was hotter than that. And we're not used to that sunshine, that heat here. So we took several breaks, and in one of the breaks I went over and worked on the 4X gun and got it working, and then we were able to change everything back and do all the rest of them with the 4X gun. So this is all ready to go back together now with the doubler, with the replacement part that'll go in here. Yeah, see, that stuff is hard now. It's set up. So I've got a piece to go in here to replace that piece that I cut out that had corrosion on it. Then I've got a doubler to go over the top of that. We're all set up to do that. Well, my wife had to work today, but I'm pretty happy with the way that turned out. That looks pretty good. That would work out nice. My granddaughter came over the weekend and worked on cleaning these floats out on the inside of them, all the compartments out a little bit. She vacuumed out the loose stuff and started picking away at the corners where I've got to put the sealant in and stuff. She did quite a bit of work on it. Whatever she did is something I don't have to do, so that was good. I got a chance to look over this patch here that was put on here that I was kind of worried about. And the patch itself is actually not too bad. It's actually a pretty good patch. The problem with it is that it was set up with some kind of epoxy resin in it for sealer instead of the right kind of sealer. So it had a big gob of it here on the outside of it, which of course popped off. And then on the inside it's got a whole bunch more of it in there. And the problem with epoxy resin is that it's brittle. It doesn't stick very well to the aluminum. It doesn't bond very well to the aluminum. Eventually starts breaking loose and popping off, and then water can go in between it and the aluminum, and it kind of defeats the purpose of putting it in there. But it also is brittle, and it starts breaking up, and big chunks of it come out. So it's not the right thing to use for repair of floats. It's something that's pretty common for people that don't know what they're doing to do. Because that's what I used the first time I repaired a set of floats. And the other set of floats that we had on the Cub, when we got it and started looking at it, it had been repaired with epoxy resin on the inside too, which is all coming out in chunks. So it's a pretty common thing to do, but it's not the right way to repair them. So I'm going to have to take this patch out of there, and I'll put it back in with some PRC 5200 so that it's sealed properly, and then I'll try to seal up the rest of the floats. Well, I thought I'd go over a little bit of the definitions or the construction of these floats. These are Ito 89-2000 floats. These floats are rated in their buoyancy. So one float of the Ito 2000s, one barrel, has a buoyancy of 2,000 pounds. 2,000 pounds will submerge the float, but it's still buoyant. It's still floating in the water, more or less, but it's almost totally submerged. When you put two floats together like that, it's considered a 2,000 pound. Generally, the gross weight on a Super Cub is about 1,750 pounds. 1,775 pounds or something like that. So it's 2,000 pound capacity floats is quite a bit overkill on the Cub. But when you start getting the bigger engines, the 150 horse engine, now the 180 horse engine, all the extra stuff that you put on the airplane, then the lighter floats like the Aqua's 1900s, then the floats start getting deeper in the water with a load on them, and so it takes more power to pull them out. People don't like these because they're bigger and heavier. It takes more power to taxi them around and supposedly get them out of the water, but they float a lot higher. Each individual float here is called a barrel, and there's two sections on these barrels. There's the aft section and the forward section. And the top of these floats, the aft section and the forward section, are two different sheets of aluminum, and they're bent round or semi-round, and it's one full sheet all the way around. So with that bend in them like that, they're pre-stressed and they're pretty strong. There's not a whole lot of oil canning or anything else in the new float. They do have ribs in them, and the ribs in them in this upper portion are kind of a hat channel aluminum. They're U-shaped and they come out kind of a little hat, and they're riveted in every, 10 inches, 11 inches, something like that. The bottoms of them have ribs in them that are made out of bulb angle aluminum. It's either 3/4 inch or 1 inch bulb angle, and they just go from here across. There's a cutout in them here for the band, and then they go across the bottom and they're riveted in. And then you have bulkheads. Of course, you have a bulkhead on the aft end, on the tail end, and you have a bulkhead on the bow end, on the forward end, to close them off. There's 6 individual watertight chambers in these floats, and each one of them has a bulkhead in it to separate those, so they're all watertight. On the bottoms here, this aft section here is one sheet. It goes up, bends over, and goes down to the other side, and then there's a chine here. And this has a chine strip that's about 1.5 inches wide on the side. That's the chine. And then there's an angle that's riveted onto the barrels here on the top sections. There's an angle riveted on there, and then those are riveted together here where they come together, where the joint is made on it, the seam. And then down the center section for strength is the keel. This is the keel section on the aft portion. Now where the two halves meet, this is called the step, and there's actually a physical step that comes down right here, and this separates the forward from the aft portion. This is where the center of pressure is on the floats. When you get them up on the step or in a planing mode, this actually makes a break in the water, and this will be the portion that's wetted here, is on the step, and then you'll have the turbulence here, and this section in the aft will actually be out of the water, won't be wet. And that's the center of pressure. That's where the load all is concentrated on the floats when you're at a high speed on the water and in the air. This is called a skeg here. It's a heavy cast section that's riveted in, and that strengthens up that step right there, because like I said, that's the center of the float, and that's where all the pressures and stuff on the float are. And then they have a keel here on the forward section, and it gives you a little bit of directional stability in the water. It's for steering and to help the floats go straight. Now, larger floats and flying boats, there'll actually be holes, vents up here on the top of the float somewhere with hoses coming down and coming out here on the step so that it injects air in on this section of the float to break the suction of the water so the airplane gets off faster. It doesn't get sucked down and stay on the water. You'd think you'd want everything as smooth as possible on these floats on the bottoms of them, so you'd think that they'd be riveted with flathead rivets, but these round head rivets, the dome head rivets, actually create turbulence in the water and inject air in there and then cause foam, which actually lubricates the water, and so it's not so sticky. These are called keelsons here. They're added on these floats. It's a bent piece of metal here, and it's just added on, riveted in. On larger floats and other models, they'll actually have them molded into the aluminum. They're actually put in a press and molded in, and they'll have them built in flutes in the bottoms of them. But these floats are pretty simple. From this side here to the center is just one flat sheet of aluminum. There's no shape to it at all except for the curve as it goes over the nose. So it's simple and cheap to make that way. So they add on these keelsons on here. And again, you have the chine here, the same thing. This barrel is made up separately, and then it's joined to this section of the barrel, and then the tops are added onto it. Now, each one of those is an individual barrel, a float, and together they're called floats, not pontoons. There's different ways of attaching floats together. Some of them have a cast pass-through where they actually have a piece that goes completely through the float, and the spreader bar slides in that and is clamped in it. On these floats here, they have these big square nuts on there, or bolts on there. Actually, they're bolts, and they're a square head, and they're eye bolt. They have a hole going through them, and they're cast, well, they're steel, probably forged steel. They go through into the inside of the float, and they have that triangular doubler there on the skin of the float, and there's a doubler on the inside, and then there's a big nut that holds that on there. Then we have two side plates that bolt into that and come out, and then the spreader bar has a casting that fits inside the spreader bar that bolts right up to that angle plate that fits on there, and that's how these floats are attached. There is a diagonal flying wire that runs from the rear attach fitting on one float across to the forward attach point on the opposite float. So it'll run from the rear right float to the front left float, and then there'll be one that runs from the other way, from the rear left float attach point to the right front one. And those flying wires are adjusted to square the floats up, and that's all there is to a set of floats. And of course you have all the water rudder rigging and all of the stuff that bolts onto that then that goes to attach it to the airplane is all separate. But these floats, the Edo 2000s, are all the same. The dimensions on them are all the same. The distance between them, the spreader bars, everything else are all the same for different airplane applications. Now, these floats are relatively flat on the bottom. There's a small, shallow rise from back here on the step to where it starts curving here, and then it curves up gradually to the bows. That's called a dead rise angle. This angle from here to the bow of the boat of the floats is the dead rise angle, and with a flat bottom with just a slight V in it. What happens there is if you have a flat bottom boat like a pram, they can run through shallow water. They're pretty wide, they're flat bottom, and so they don't draw much water. They can run pretty shallow water. The disadvantage to them is they pound like crazy with any kind of chop or any waves or anything. It just hammers on them. So these floats are something similar to that. I've seen floats that are completely flat bottom and they would pound quite a bit. These have a little bit of a V in them. It's just a shallow V, more pronounced to the front than it is towards the back. So they have a tendency to pound in the waves. Other types of floats, aqua floats, whip lines, I believe the Aeroset floats have more of an angle in the bow here. They drop down at a sharper angle, and then they have flutes in them, and this angle here on the bottom is a little bit sharper, so they cut through the waves better, so they're not quite as rough. And then they'll steer a little bit straighter. They'll stay straight in the current a little bit more. The Edos will have a tendency to wander a little bit more, because they don't have as much of a keel effect on them. The effect of the keel of the boat cutting down into the water and being deeper in the water. The corollary to that, of course, is that the deeper floats with the sharper angles on them and the sharper dead rise angle with the steeper V on them sit deeper in the water. These floats like this, where they're pretty much flat from here back and flat from the center out here relatively compared to the other floats, means that they don't draw as much water, so they can operate in shallower water. So the other floats with a steeper V, a deeper V, and a higher dead rise angle they float deeper in the water. The keel, the deepest point of the float, is going to be deeper in the water. But one of the other costs with this flat bottom, low dead rise angle, very shallow sweet spot. When you get it up on the step, there's only so much of the float that's wetted. But because these floats are flat, if you don't have your angle of incidence of the airplane just right, then more of the forward section of the float is going to be wetted and it's going to be sticky on the front. And if you pull back and change your angle of incidence to nose up, because these aft section of the float is shallow, the aft section of the float actually drags in the water and slows you down. Whereas the floats with the deeper keels and the sharper dead rise angle, their sweet spot will be about the same place here. There'll be less float in the water, but there'll be more of the float dropping away in the front. So the angle of incidence that you operate at is wider. You can have the nose down more, and you're not going to wet the forward area of the floats, and it's not going to suck you down in the front. And if you pull back, your tails aren't going to drag in the water. You have more that you can pull the nose up without dragging the tails in the water and sticking you down. So on those floats, a lot of times you can rotate the float airplane and rotate it out of the water and get it flying sooner, whereas a typical Edo float is flat here, and if you go too far forward, you're going to get more suction on the front, more stickiness on the front. It's going to slow you down. If you pull the nose up a little bit, it's going to get sticky on the tail and it's going to slow you down. So you basically have to fly the airplane out of the water. One of the other things that happens on these floats, and it'll happen on any float, but it's more susceptible on floats with a low dead rise angle. If you go too far forward on this forward section gets wetted, and the water here will actually start pulling the floats into the water. The more of it that gets wetted, the more it pulls you forward, and the more it gets wetted and the more it pulls you forward, and you actually get suction pulling you down in the nose. And so if you land the airplane at speed with the nose angle too far forward, it'll actually pull you over, and you can flip the airplane over and do a ground loop, or a water loop is more properly termed for it on a float, or you can just flip the airplane over on its nose. Once it reaches a certain point here, if you're right on it and feel it, you can pull the nose back, pull the elevators back, and get the nose to come back up and correct for it. But then what happens is you bounce, and then you overcorrect, and the tails hit the water, and then they hit the water first, and that slaps you down on the water. Then you come down too far forward on it, and then it creates more suction on the front, which pulls the nose into the water. So it can be a pretty dicey situation there if you don't keep absolute control on your angle of incidence when you're touching down on the water, or when you're operating at speed on the water. You have more leeway on the floats with the higher dead rise angle, with more of an angle between the step and the bow of the float. But because your angle is even farther forward on it, when you do start grabbing on those, the action is actually even more violent of pulling you down.